This is a very simple question. Which the following combination will produce H2 gas? It is a single choice question, so only one option remains: is zinc plus, that is your 2OH minus. Directly you can hit. The answer is basically your C. Zinc plus 2OH minus will give you plus 2H2O, plus 2H2O, plus 2H2O will give you ZnOH4 minus 2. It's a complex, you know, because basically zinc hydroxide gets precipitated, and with excess alkali hydroxide, the sodium hydroxide dissolves plus hydrogen. So this is the reaction where hydrogen gas can be evolved, generally plus H2. This is the reaction. Accepting zinc, no one will give. Iron will not give. With concentrated nitric acid, it gives you NO2. Copper also gives you NO2. Sodium, gold metal with NaCN and presence of air gives a complex, never hydrogen. So this is the answer, question number 22C. Next we will go to question number 23. In question number 23 is another interesting question. Question number 23. The answer, I must first tell you that the answer will be a C. The answer will be a C. Why? Because look, H3PO3, it is given the order of the oxidation of the phosphorus atom in these few acids. For example, if I talk about H3PO4, the structure is HOP, double band O, double band O, double band is H3PO4, OH, it is a OH H3PO4. So obviously, 3 bonds and these 2 bonds gives you phosphorus plus oxygen state, and then it is given as P2O6, that is a PP, that is basically hypophosphoric acid, PP double OH, let's say it is a OH, it is H4P2O6 is OH, it is a double band O, and double band O, it is a OH, it is a OH. This H4P2O6, it is called hypophosphoric acid, phosphoric acid, it is orthophosphoric acid, phosphoric acid. I know all of you know how to calculate 2 bonds with more electronegative element, less electronegative element. So it gives you plus 2, it gives you minus 2, 1 bond over here, plus 1, minus 1, over here, plus 1, minus 1, and in both are phosphorus, all are sp3 hybridized, so whole the oxygen state is plus 4. The phosphorus is basically, this phosphorus is in plus 4 oxygen state, this phosphorus is in plus 5 oxygen state, and then if you see the H3PO3, and H3PO2, this OH, P double band O, it is your H, it is your OH, this is H3PO3. Clearly, these 4 bonds will give you basically H3PO3, H3PO3, 3H, and H3PO3, I think, yes. So naturally over here it is plus 1, minus 1. Here it is plus 1, minus 1, it is plus 2, minus 2, over here minus 1, plus 1. So obviously in total you are getting basically plus 3 oxygen state for phosphorus acid. This phosphorus acid, and for instance H2PO2, I am getting another sample, that is pH, it is an H, double bond, it is an OH, it is H2PO2. Clearly same concept, that means basically 3 and then minus 2 is plus 1. So now you understand that this phosphorus is plus 1, this is hypophosphorus acid. This is hypophosphorus acid, So therefore these are the oxygen numbers, the distribution, so we can get the answer out of this. So next question, we'll go to 24. Next we'll go to 24. Question number 24. It is a very interesting question. It is a diazonium coupling reaction basically. You understand, everybody knows that primary aromatic amine in low temperature gives basically diazonium cation, it is NH2, it is basically OH. Now if you give NN2HCl number 1, NN2HCl, what it does, I will write step by step. HCl, I hope 0 degree to 0 degree centigrade given, so it will give primary amine, it will convert to N2 plus, this gives you N2 plus, and it is your this, and obviously this will be your O minus, this is OH because acidic medium, and once you are giving OH minus, second reagent is OH minus, so obviously you will get in this particular ring O minus, you get O minus acid base reaction. OH minus will take this proton to give you O minus, and over here there is diazonium cation, benzene diazonium cation is present over A, double bond in class. Basically, it is a weak electrophile. Everybody knows it is a weak electrophile. Weak electrophile because of cluster delocalization from nitrogen into this nitrogen and then to benzene ring. So cluster does not stabilize on this nitrogen for a long time. So obviously, since it is a orthoparadiating group and obviously it is a paradiating group very much, so therefore you will get the coupling, CN coupling. We get CN coupling. The product will be this and this. It will be like this. It is O minus. It is N, double bond N. It is like this, and over here it will be like this. So that is the answer. So answer will be your C. C will be the answer. C will be the answer. They should have given in form of O minus. They have given in form of the OH, but the acidification, but basically it is OH minus. So it will keep like O minus. So that is the answer. So that is 24. Answer will be your C. 24 answer will be C. It is O minus. In basic medium, it is O minus. It will not be OH. It is the wrong from their part. Next, we will come to question number 25. Question number 25. Next, we will come to question number 25. Another interesting question. Another interesting question. Question number 25. Question number 25. First, I might write the answer as C. I will write the answer C. Why? Because see, there is the strongest base guanine have been given over here. NH double bond. It is a C. It is your NH2. It is NH2. Everybody knows this is the NID level preparation. Everybody knows this is called guanidine. It is the strongest base in organic chemistry. Strongest base. Strongest base. Strongest base. Obviously, this is the strongest base. So this is basically 4. So this is your 4 option will be at the topmost basicity part. So 2 options were there, B and C. So here they will be compared basically 1 and 3. Anyway, 4 greater than. Look, which one is the after 4? Which one should come? This is again 1. So therefore it should be 1. Why? Because just you have removed one. You have removed just one amine group and you have given CH3. That is this double bond NH. It is your NH2. You have just removed one amino group by methyl group. So obviously function is remaining same, almost little different. Like what happens is that I tell you this comes and this builds up electron density on this nitrogen. So what happens is that it is your NH minus. You can say double bond NH2 plus. Like this it is your NH2. So that means what? There is a huge electron build up on this. So this basically donate the lone pair to the proton. So that means what? If I write this in presence of H plus, the lone pair coming from here will attack to give you NH2. It is a C double bond NH2 plus and it is your NH. So now this NH2 plus can be stabilized by resonance like this. So I can draw the resonating structure like this. There this. That is, it is double bond NH2 plus. It is your NH2. It is your NH2. Similarly, this can come over here. This can come over here. So we get equivalent resonating structure as. We get equivalent resonating structure as. That means we get equivalent resonating structure out of 1, 1, 2, and another one 3. If I get, then equivalent resonating structure becomes NH2 dot C dot NH2 dot NH2. It is your plus 1 by 3, plus 1 by 3, plus 1 by 3. So obviously this is very stable because it is an equivalent resonating structure. Equivalent resonating structure, so it is very stable. Since conjugate acid is very stable, so it is strongest base, and obviously this will come after that. So therefore there is no confusion that 4 greater than 1, then greater than 2, greater than 3. 3 will be least basic because you know the nitrogen. If you see the third compound, third compound is what? It is like this. N, it is your H, it is like this. N like this. Just look at that this lone pair is basically into resonance. So that means this lone pair is relatively free to be donated. But this nitrogen will have a pooling by this nitrogen. So obviously this donation will be least. And also there is sp2 carbon, there is a minus I effect. So many things are there. So therefore this nitrogen will be least donable. So that is the answer. So therefore this is the best technique to answer this question. Next question, we'll go to section 2. Section 2. In section 2, we have got the 7 questions. It has 7 questions, one or more than one is correct. So it is difficult part to answer, because there is probably yes negative marking is there -2 and class 4 is basically this. But interesting, there is a partial marking, excellent. So therefore we should answer this question this way. Question number 26, for example, question number 26. It is given absorption is accompanied by decreasing. Everybody knows that if the gas is like this and particularly in the surfaces like this, gas is absorbed on the surface. So in that case, delta H will be obviously negative, and especially chemisorption, delta H is a chemical bond forms. So delta H negative. Any kind of absorption on the surface of the substance gives you delta H negative. Be it a physical absorption, be it a chemical absorption. Yes, chemical absorption gives more, and it is more exothermic. And also delta S, obviously, if these gas molecules were random, but once this is absorbed on the surface, they become more disciplined or more, you can say, less randomness appears. So therefore, delta S is positive for absorption. This is correct. So therefore, A option 26 is correct. B option, the critical temperature ethane and nitrogen are given. So obviously, absorption ethane will be more than the nitrogen or same amount of activated charcoal at given temperature. Yes, more critical temperature is if it is more, then that means what? That the absorption capacity of the charcoal will definitely increase. And cloud and emulsion type of colloid in which liquid is dispersed and gas is dispersion medium. Basically, your emulsion. Emulsion is basically liquid in liquid, not liquid in gas. That is not called emulsion. Emulsion basically liquid in liquid basically happens. So therefore, A and B are correct option for this. But no worries, never worries, there is a partial marking too. Next, question number 27. Question number 27, let us talk about question number 27. Beautiful question. It is given that for a reaction taking place in a container in equilibrium with the surroundings, the effect of temperature on its equilibrium constant K in terms of change in entropy is described by. Just look at the question. See, we know that delta G naught is equal to delta H naught minus T delta S naught. Just come from the basics for this particular equation. Now we know that delta G naught equal to minus RT ln Kp. Okay, see anything, let's say Kp I am writing is equal to delta H naught minus T delta S naught. So obviously what we get ln Kp is equal to minus delta H naught by R into 1 by T plus delta S naught by R. So therefore, this is basically Van Top's equation. This is basically Van Top's equation, which depends on basically the temperature. It depends on temperature only, considering that delta H naught, delta S naught fixed. Now, one by one, we'll analyze this particular question. That see, first they are saying that A option. They are saying that they're saying that the effect of temperature on equilibrium constant K in terms of change in entropy is described by with increase in temperature. Just look at for this case here increasing temperature and increasing temperature value for K for delta H. Delta H, they are saying that there is a external reaction. Delta H equal to negative. Delta H is negative. Delta H not equal to negative. They are saying, and also saying decrease because the entropy change of the system is positive. And delta S naught, they are saying is positive, and they are saying that equilibrium constant is decreasing. Equilibrium constant is, they are saying the system is positive, decreases. With increasing the value of K for external reaction decreases. They are saying the confusion is Kp is decreasing. Just put this condition over here. Delta H naught is negative. So negative, positive becomes positive. This is this, and delta S naught positive. If it is positive, obviously with increase in temperature, Kp with increase in temperature, denominator is increasing. So obviously what the value is reducing, so Kp will decrease. So therefore it is correct. A is correct. Next B, if we see B. B is saying with increase in temperature, then again saying increase in temperature they are saying, and the value of K for endothermal reaction, delta H naught, they are saying it is positive. Delta H naught is positive, and they are saying that it increases because unfavorable change. That means they are saying delta S naught equal to negative. Unfavorable change means entropy negative, and entropy of the surroundings, change in entropy of the surroundings decreases. With increase in temperature, the value of K increases. They are saying K is increasing. See, for example, over here, see, here we talk about delta S naught of the system. Actually, we talk about the system. We talk about the system. So, if it is so, now they are saying that entropy of the surrounding decreases. That means entropy of the system is increases. Entropy of the system is increasing. So, therefore, with increase in temperature increase, and delta H naught, they are saying that it is your delta H naught. They are saying that the value of endothermic reaction. So delta H naught is now it is basically positive. So positive negative becomes negative. So if you increase temperature and delta H naught system is positive, it is positive. Good thing. It is basically negative with decrease in temperature. So that means this negativity basically decreases, positivity increases, so Kp will increase. This is correct. So therefore B is also correct. Likewise, if you see question number C, if you see, then number C, if you check number C, again same expression as that, with increase in temperature and value for K for endothermic reaction. So delta H naught is again it is equal to positive. Delta H naught is positive because entropy change of the system is negative. Delta H naught is equal to negative, and what they are saying Kp, the value of Kp for endothermic reaction increases. They are saying increases. Whether it is correct or not, we have to check it. Now again over here delta H naught is positive, so over negative, and T increases. That means what? If negative it is basically, then obviously with increase in temperature this value reduces, negativity reduces, and delta S naught is also negative. So negative and negative, both are negative, will cause Kp will basically decrease. So C is not correct answer. And if you talk about D, with increase in temperature, so again the temperature increases. They are saying, and value of K for exothermic reaction, delta H naught equal to negative exothermic, and also K for external reaction, they are saying Kp is decreasing. They are saying favorable change in entropy of the surroundings. That means delta S naught is equal to negative for the system. Surroundings favorable means system, delta S naught negative. So in that case, you can see that once again it is all system basically I am talking about. So here delta H naught negative, positive. If it is positive, so T increases. So that means what? This value basically decreases. So if it decreases and delta S naught system is also negative, they are saying, so obviously it is negative. It is decreasing, it is also decreasing, so Kp has to decrease. So therefore B is correct answer. So therefore we have concluded that A, B, D are the correct answers. So this is all the basic fundamental equations. They have asked the physical chemistry questions. Wonderful that they are not asking our students community, the whole of the nation, that only numericals will tell you will make you the understanding to the physical chemistry. No, not the numerical. It is the conceptual part we should know beforehand, especially GE advanced paper. Next we see question number 28. This is a question number 21. One of the very interesting question. Unfortunately, I will not be able to deliver. Derive so many things before you. I can, in future I can upload some of the part of this. But yes, it's a very interesting question. Just for example, in a biomolecular reaction, the steric factor P was experimentally determined to be 4.5. What is P basically? We know that rate equal to, if you see the NCERT you also get, it is basically P into Z into e to the power minus EA by RT. This is basically P. This Z is basically, this Z is number of collisions, number of binary collisions, and this P is the steric factor basically, or steric factor, or we can call it this basically, this is basically the steric factor we can call, and then or we can say the it is the steric factor, and P is the steric factor, and Z is number of binary collisions, and EA is the activation. This is the activation energy. EA is the activation energy. You know the basic equation. Activation energy. Just for example, if I say this many molecules are over here, these many molecules that were here, which are basically colliding. So if this is EA, then obviously if the number of molecules over here is N0, and how many numbers of N molecules will be there? N equal to N0 into e to the power minus EA by RT. This is by Maxwell-Boltzmann distribution. How many molecules that act as energy? It is energy basically, and this is nothing but number of molecules at the activated state N0 in terms of whole molecule at ground state is N equal to N0 into the power minus EA by RT, corresponds, it basically approaches to this expression. Finally, and rate equal to P into Z into e to the minus EA by RT. Now, first option, what they are saying that the correct options among the following are: the activation energy of the reaction is unaffected by the value of the steric factor. Yes, activation energy is fixed quantity, is a fixed quantity, it cannot change. So therefore A is correct. So therefore A is correct, that activation energy cannot be disturbed by any, the steric factor or the probability factor. Next, second, B, experiment determined value of frequency factor is higher than that predicted by Arrhenius equation. Basically, actually we know the calculated values is, if you see, basically calculated values of K are much higher than the experimental, So therefore what? Much higher. Calculated values are much higher than the experimental. That means what? Obviously, if the K changes, then obviously A will change, or they're saying that frequency and P will change. So P will be definitely higher for the calculation part, and experimental value is lower. So therefore B is, so experimental they are saying higher, basically calculated values are higher, so B cannot be the answer. Then C, it is all knowledge you have beforehand. Next, C, since P equal to 4.5, they are saying P equal to 4.5, the reaction will not proceed unless an effective catalyst is used. See, there is no question of using catalyst and the P factor. P basically the steric factor. For example, I want to tell you, let's say HI molecule, 2 HI molecule giving you H2 plus I2. Now how it can form? They can basically collide like this. HI molecules, they are coming from this direction, and they will make this kind of bonding, and then finally lead to H2 plus I2. This is basically the probability or the approach of the H2 and I2 molecule towards each other. Suppose if HI molecules if approach like this, so naturally they will make the transition state. You can see by collision it is I and it is H, it is like this. So it is a fruitful collision, it is not a fruitful collision. Again you are getting 2 HI from HI. So therefore what? P basically corresponds to the steric factor, or you can say the orientation factor, how the molecules are approaching. Suppose here the molecules are approaching like this, for example, HI molecule is coming like this, toward this, then they will make the activated state, and they will convert to H2 plus I2 by collision. So this is basically the steric factor. Steric factor does not, this P value cannot give any indication whether a catalyst can be used or not. So P basically to make the experimental and theoretical rate constant equalize, almost normalize. So therefore P doesn't have anything. So therefore C definitely will not be the answer. And then D, the value of frequency factor predicted by Arrhenius is higher than the determined experimentally. It is correct. It is correct because the actual if you see the derivation of the Arrhenius the experimental, theoretical approach of K, rate constant, you can have the final expression that K equal to the right, that is equal to your sigma A plus sigma B whole square into sigma plus sigma B whole square N0 by 10 to the power cube into square root of pi RT divided by 2. This mu is the reduced mass, e to the power minus A by RT. So this is basically the final expression K for a binary bimolecular reaction where sigma A and sigma with the molecular diameter and the Avogadro number, and you know this whole the value basically corresponds to basically A. And so obviously I can see that A dash root over T into e to the power minus E by RT, and what basically Arrhenius said that this is almost equal to A is constant into e to the power minus E by T. If you see very carefully, we say that Arrhenius said that A is not a function of temperature, but theoretical calculation shows that it is a function of temperature, but linearity, because it is linear equation with respect to L and T, and this basically this root T value is very small with respect to Ln within Ln, so therefore we can neglect it. So what is almost A is not a function of temperature. Actually, it is a function of temperature. So this is there is a whole picture for the derivation in final form. This is the final form to your K value. So this whole is basically A. Now the question is that the value of frequency factor predicted by Arrhenius equation is higher than the experimental observed. It is correct. So D is basically correct. Experimental value, experimental frequency factor predicted by Arrhenius is higher basically than determined experimental, because you know K experimentally found and K calculated. K calculated is always higher than the K experimental. So therefore this D option is correct. Next we'll go to question number 29. Then question number 29. Question number 29. For the following compounds, the correct of statements with respect to nucleophilic substitution reaction are. See, nucleophilic substitution reaction, that means they are not mentioning that whether it is SN1, SN2, what type of reaction they are asking for. So that means you have to understand by the question that whether they are asking SN1 or they are asking SN2. For example, they should mention actually whether SN1 or SN2 are the given conditions. Like aqueous solvent can give you SN1, acetone solvent give you SN2, presence of nucleophile gives you SN2, no nucleophile solvent, particular solvent is acting in a solvent, is all can act as a nucleophile in SN1. So many things to be given. Anyway, if not given, at least you can predict. Suppose the question compounds are given very simple. There is that is benzyl bromide, CH2Br, this is 1. So 1. Second compound is given as cyclohexyl methyl bromide. Cyclohexyl methyl bromide is 2. And number 3 over here, I'll write over here CH3, CH2C, CH3, CH3Br. So it is your 3, and then 4 is basically 4. I'll put over here. It is they're creating another reinforcement of the carbocationic character, because benzyl cation is stable, including methyl can give more amount of this thing your SN1 character, but fortunately the question is based on SN2 basically. So now 1 and 3 follows SN1 mechanism. Option A. They are saying 1 and 3. Yes, 1. Why not? If it is cation, it's very stable. So the 1 can follow and 3 can follow SN1, because 3 degree only undergoes SN1 reaction for your information. So therefore A is correct. Then if you see B, 1 and 2 follow SN2 mechanism. See, it is 1. Yes, it can follow SN2. Because why it can follow SN2? Because it is 1 degree, phenyl minus I and bromine minus I, delta plus tremendously high. Yes, it can go very good SN2 character. So it is SN2 reaction. So 1 can follow and 2 also can follow, because 2 degree is 1 degree high. So obviously it can undergo SN2 very nicely. So B is also correct. If you see the number C option, compound 4 undergoes inversion of configuration. Compound C, compound C is this. Over here, yes, SN2 can take place because 2 degree and benzylic. So SN2 can take place. Suppose if I say nucleophile given, so obviously if it is R, or if it is let's say it is let's say I am giving nucleophile, so it will later over here, it will go out. So there will be inversion of configuration. That means if I can show it very nicely, you can see it very nicely that I can say like this, like this. Over here I am showing this. Let's say it is your H, let's say it is a CH3, or let's say it is an H, let's say it is a CH3. So nucleophile can easily enter to the inside, and this bromine can go. So you can get the product, inversion product, CH3. Over here like this, it is a hydrogen. Here it is like this, benzene ring. It is your benzene. Sorry, this, and this benzene ring. and this is your nucleophile. So yes, there can be inversion, Walden inversion. It's called Walden inversion, a SN2 mechanism. Walden inversion. So it is a SN2 mechanism. Yes, it can operate. So therefore, our answer C also is correct. And if you see the D, the order of reactivity for 1, 3, 1.